Hello and welcome to this 5-minute short looking at Piper and what I'm calling long thin pipes. So this is where you've got a pipe diameter and a decent section of pipe work. But let's show you an example, make more sense than me waffling on. So here we've got a very simple Piper model. We've got some sort of contraction, an inlet here and an expansion to atmosphere in this particular case. If I double click on the pipe, you'll see we've got some roughness, but it's a 5mm pipe. So in this sort of example, we're looking at something like a leak and want a 5mm orifice. But for whatever reason, this is 1 meter long. So long and thin pipe is where it came from. So that's our pipe work. Just to show the rest of this, if I go to conditions, you can see we're going to define this particular example by the inlet and exit pressure. So I'm saying it's 12 bar gauge on the inlet, going to atmosphere on the discharge. I've got an inlet temperature of 150 degrees C. So I'm going to define this one by temperature rather than by mass fraction. And then for completeness, we go to the physical properties. You can see we're just going to use nitrogen. And for the VLE, we're just going to keep it as the default PSRK. It's nitrogen. That should be absolutely fine. So a seemingly simple kind of example. And I press calculate. This is going to twirl and I'm going to get a whole heap of error messages all around the physical properties saying it's failed, and we're like, what on earth is going on here? A lot of information, none of it particularly good. Now it's I guess it was a feature of Piper, is the way Piper works is it tries to break that long thin pipe into little chunks, and it's rigorously doing the physical properties as it goes through, but it's also checking for chokes. Bear in mind we've got 12 bar here, atmosphere here. There's something like some sort of discontinuity going in here, and it's just causing the solver a lot of issues. So if you get something like this, we need a practical way of solving this. And the model looks a little bit strange, but it does actually work. So what we're going to do is we're going to split this long thin pipe into little chunks, just to help the solver do this little bit of pipe, this little pipe, this bit of pipe, and just help it converge in a more successful way. So the way we're going to do that, we're going to use these joins here. I'm going to drag this join onto here. Now, one of the things, if you're doing this, of course, you want to keep the original length the same. You don't want to start creating more and more pipework. That's going to get a little bit confusing. So this is where if we go to our options tab and behavior, we can change how the model behaves as we drop other items in. So at the minute, if I drop that join in, what will happen is it will split the pipe, but it will keep the same length either side. It will basically double the size of my pipe work. In this case, I don't want that, but I want to split it in half. And I split it in half, no matter how many of these I drop, it's going to keep splitting in half. The total length should stay the same. So I'm going to stick with that. And I'm going to, let's demonstrate this. So this is 1 meter. I'm going to pull this in, drop it in there, and then you're going to see that's 1/2 meter. And that's 1/2 meter. So that's the beauty of that functionality. Again, just to show you, if I change that option and change it to same length, at this side now we've got 1/2 meter. There we are, 1/2 meter. If I drop to join in, you can have 1/2 meter that side and 1/2 meter that side. So it's double the size of the pipe, which is obviously what we didn't want. So let's undo that. So that's the idea. And we're going to put a lot of these joins in. And typically when we do these, 10 seems to be a good number. It's a long thin pipe for some reason. And instead of watching me doing that in true Blue Peter fashion, I'm going to produce this. So I have 2 Piper models open. This is where you toggle between the 2. So I've literally dragged and dropped a lot of joins in, splitting up. They don't all have to be the same lengths. It doesn't have to be perfectly split out. As long as there's little chunks, the overall length's what you need to be, then that's absolutely fine. There's a way of checking that. If you click the edit fittings, you can see all these lengths here, and you can add all these up and I'm sure someone will do on screen. Hopefully that equals the right number. But it was half and half, so I'm believing myself that that is correct. So apart from that, the conditions exactly the same as we had before. 12 bar to atmosphere. We've got our physical properties. Nitrogen, VLE is PS Arcade, exactly the same. And then we're going to press calculate. The solver's going to go and have a think. And then we've got a result. So because we've managed to split this pipe up into little sections, it's just helped the solver go through that pipe work, keep iterating through. It's not hitting inconsistencies. It solves relatively quickly, relatively stably, one much more stable than the other one because it gave us errors, and it gives us an answer. So if you are seeing these sort of errors, this is a good sort of tip, technique to get to a successful result within Piper. I hope that was useful. Thank you very much.